Welcome back, everyone, for another deep dive. This time we're going, getting a little bit dirty, I guess you could say,
Yeah.
with looking at red Californian earthworms and how they can help us deal with all the organic waste that we produce.
Right.
And I know you send over a research paper
Yeah.
looking at specifically using bovine and poultry manure in vermicomposting.
Yeah.
So I'm really interested to see how these little guys perform on that kind of diet.
Yeah. It's it's a great way, I think, to look to nature for solutions to some of our pressing problems.
Yeah.
And in this case, the problem is how do we deal with all this waste?
Yeah.
And this paper really kind of goes beyond just dealing with the waste.
Right.
Talking about creating a valuable resource that can actually improve soil health.
Exactly.
And support sustainable agriculture.
And that's really what I love about doing these deep dives. It's like, see, how can we turn this problem into a possibility?
Yeah.
But I think before we maybe get too far into the weeds,
we should maybe back up a little bit and just look at the sheer volume of waste that we're talking about here in agriculture. And, this paper highlights the poultry industry specifically.
Yeah.
And I think I read something like 7 kilos of manure per 1,000 kilos of live weight every day.
That's right. It's, close to 7 kilos. And that's just the poultry.
Yeah.
So when you start to add up, all the different livestock and agriculture, it's just this massive amount of waste. Yeah. And if we don't manage that properly, it can become a major pollutant contaminating water and soil.
Of course.
So vermicomposting offers a really nice solution. It's a way to naturally and efficiently break down this waste, but then also turn it into something valuable.
Okay, so we're talking more than just a compost pile in the backyard here.
Yeah.
So what is it about these earthworms? Eisenia fetida.
Eisenia fetida.
If I'm pronouncing that correctly.
That makes them so good at this.
So these worms, they're like tiny little recycling machines.
Yeah.
They ingest the organic waste.
Yeah.
And they break it down into this nutrient-rich humus.
Right.
Which is essentially compost.
Yeah.
But they do more than just decompose the matter.
Okay.
They create tunnels as they move, which helps aerate the soil and improve its structure.
Really?
So yeah, they're pretty amazing little creatures.
That's really cool. I never thought of it that way, that they're actually, helping to aerate the soil at the same time.
Right.
And this paper really kind of looked at, I guess, the different effects that different waste types had on the worms.
Exactly.
Right.
Yeah. So they looked at 3 different mixtures.
Okay.
One with 100% bovine manure, and then 2 others that incorporated some poultry manure.
Okay.
One with 20% and another with 40%.
Okay.
And they tracked all sorts of factors, earthworm growth, reproduction rates, the quality of the compost, the leachate.
Oh, yeah, the leachate.
Yeah, which is that liquid byproduct.
So we're not even just talking about, solid compost. We're talking about a whole nother product as well.
Exactly. Gives you a real insight into how complex this whole process is.
Wow.
But before we look at those results, I think we need to talk about pre-composting.
Oh, yeah, pre-composting.
Yeah, which is a really important step they took.
Okay, so why is that important?
Before they even introduced the worms.
Yeah.
I mean, can't you just kind of throw it all in together and see what happens?
Oh, yeah, you could.
Okay. But it's really about, creating this ideal environment for the worms.
Okay.
And it's a process with several stages.
Okay.
And each stage has its own kind of microbial activity and temperature range. The first stage is called the mesophilic stage.
Okay.
And that's where bacteria start to break down the waste and generate heat.
Okay.
And then it moves into this thermophilic stage where the temperatures can really soar, sometimes up to 70 degrees Celsius.
70 degrees Celsius.
Yeah. So that's hot enough to kill off most pathogens.
Wow.
But it would also kill the earthworms.
So this is like cooking the waste before.
It is. It's like cooking the waste before you add the worms in.
Gotcha.
And then the final stage is called the maturation stage.
Okay.
And that's where the compost cools down and stabilizes.
Right.
And this creates that ideal environment for the worms.
So it's all about monitoring those, temperature and pH and moisture to make sure that it's all going according to plan.
Yeah. Throughout the whole process, you got to keep an eye on things.
Yeah. So it's really cool how much science goes into this thing that seems, kind of basic and, down to earth.
Right.
So after they did this pre-composting, what happened when they finally introduced the worms?
Okay. Well, the results were actually pretty surprising.
Oh.
They found that the highest earthworm reproduction rate was actually with the 100% bovine manure.
Really?
Yeah. And as they added more poultry manure, the reproduction rate actually declined.
That's interesting. You'd think that a more diverse diet
you would think
would mean more baby worms.
Exactly.
Yeah.
So, yeah, we don't know for sure why that is.
Right.
It could be that the chemical composition of the poultry manure is less palatable to the worms, or maybe there's something in it that interferes with their reproduction.
Oh, interesting.
But the researchers actually suggest that further investigation into diverse waste mixtures could reveal that ideal balance for optimal worm reproduction.
So it's like we're really tailoring the diet for these little composting machines.
Yeah.
Okay, but what about the quality of the compost and the leachate itself?
Right, so that's where things get really exciting.
Okay.
The analysis showed that both the compost and the leachate produced in the experiment were really rich in nutrients, exceeding standards for agricultural use in some cases.
Wow.
And one of the key indicators of compost quality is what we call the CN ratio.
CN ratio.
Which is the ratio of carbon to nitrogen.
Okay, so what is a good CN ratio?
So a balanced ratio is essential for efficient composting.
Okay.
And it tells you about the maturity of the compost.
Okay.
If the ratio is too high, the decomposition process slows down.
Yeah.
If it's too low, you risk losing valuable nitrogen.
Oh, okay.
And in this study, the compost and leachate had excellent CN ratios.
So it means it was good quality.
Yeah, it means it was mature and ready to provide optimal nutrition to plants.
So we're not just talking about reducing waste. We're talking about creating like a high quality fertilizer that can replace synthetic fertilizer.
Exactly. And that's key because, vermicompost doesn't just add nutrients.
Yeah.
It improves soil structure. It increases water retention. It boosts microbial activity.
Oh.
And all of that translates into healthier plants, increased crop yields, and just a more resilient food system.
That's fantastic.
Yeah, and it can outperform synthetic fertilizers in some ways.
Wow. So this is really...
especially in the long run.
Taking something that was seen as, a problem and turning it into a solution.
Exactly.
Yeah, and a way to nourish our soil and grow our food.
That's the beauty of it.
That's really amazing.
Yeah, we call it a circular economy.
Yeah.
Where waste is a valuable resource that could be reused and recycled.
This is really inspiring. So we've really gone from mountains of manure to fertile fields full of possibilities.
Oh, correct.
But I feel like there's so much more to talk about here.
Oh, yeah, definitely.
What else is in this paper that is, just fascinating or that we should really kind of dig into next?
Yeah, absolutely. I think what's fascinating is that this is really just the start.
Right.
They looked at bovine and poultry manure, but there's all sorts of organic waste out there.
Yeah.
Food scraps, yard waste, even industrial byproducts.
Right.
And each one of those has its own kind of composition.
Yeah.
And it's going to break down differently.
So there's still so much we don't know about how to utilize all those different waste streams.
It's like each waste stream needs its own recipe.
Oh, that's a great analogy.
Yeah. If you were trying to bake a cake with different types of flour, and you didn't adjust the recipe,
right,
it wouldn't turn out very well.
Right. It wouldn't be a very good cake.
No. So it's the same with vermicomposting. We need to understand those unique characteristics of each waste stream and fine-tune our approach.
Yeah. And that includes like the pre-composting
Exactly.
steps. Yeah.
Could we tailor that process to get even better results?
That's a really good question. It makes me think about this whole...
Yeah.
We always talk about waste management as a problem, but what if we started thinking about it as an untapped resource?
Well, that's exactly what the circular economy is all about. It's, instead of that linear model of make, dispose, we shift to a system where waste is a valuable input for new products and processes.
Yeah. I mean, it's amazing because they only looked at a 97-day period.
Right.
What about the long-term effects of these different types of waste on the worms and on the soil health?
That's a great point. Longer-term studies would give us so much more information about how sustainable and resilient these systems are.
Exactly.
Like, do certain waste mixtures lead to a decline in earthworm populations over time?
Exactly. Are there like cumulative effects on the nutrient levels?
Exactly.
Oh, those are
microbial activity in the soil.
That we need to answer if we want to implement this on a larger scale.
Right. And it's so interesting to think about these systems as they evolve over time.
But it's not just about scientific research, though, right?
Right.
We need to think about how to make this technology accessible
yes,
and affordable,
for everyone,
for farmers and for communities around the world.
Absolutely. How do we make it practical for everyone?
I'm picturing like community composting hubs where people can bring their food scraps,
right.
and, their yard waste,
exactly,
and create this, local source of high quality compost and reduce the burden on landfills.
That's a great vision.
Yeah.
And it really aligns with that concept of decentralized waste management.
Yeah.
Empowering communities to take control of their waste streams
and
actually create value from it.
Yeah. And we can't forget about the real heroes here.
The earthworms.
The earthworms, yeah.
Yeah, they're like these little ecosystem engineers working away underground.
Yeah. Breaking it all.
Breaking down that organic matter, aerating the soil.
Yeah.
Creating this foundation for healthy plant growth.
And this research highlights, that we need to understand their needs and their preferences.
Exactly.
And, we talked about how the 100% bovine manure was the winner in the study.
Right.
But I think they also emphasized that we need to investigate these different
mixtures. What is that ideal balance?
Yeah.
What do they like to eat?
What do they like to eat?
Yeah.
What don't they like to eat?
Exactly.
It's like we're creating a buffet for them.
We are.
And seeing,
we need to figure out
what are their favorites.
Their culinary preferences, so to speak.
Exactly.
So that we can optimize, their productivity
and
the quality of the compost.
It's kind of like all this research on the human gut microbiome.
How interesting.
And how important diversity is.
Yeah.
I wonder if that kind of applies to,
That's a great connection.
The compost.
Yeah, because, just like our gut microbiome is so important for our health.
Yeah.
The microbial communities in the compost are essential.
Right.
For breaking down the organic matter.
And releasing those nutrients. So it's not just about feeding the worm.
Exactly.
It's about feeding like a whole ecosystem in that bin.
It's about creating that thriving ecosystem.
Oh, wow. So we've got bacteria, fungi, protozoa.
All sorts of things.
Yeah.
All working together in there.
That opens up a whole other, avenue of research to look at like how do these different waste mixtures and pre-composting techniques affect those microbial communities.
Exactly. It's a very complex web of interactions in there.
Yeah.
But understanding those interactions, I think, is really going to be key to optimizing this and making even better compost.
It's like we're looking into this,
a secret world.
Yeah. Yeah. And who knows, maybe we'll even discover, new species or new microbial interactions that have applications beyond composting. Right.
Imagine, finding microorganisms that can break down plastic.
Exactly. Or toxins.
Yeah, that would be incredible.
Yeah. So there's a lot of potential there to solve other environmental problems.
Okay, so the possibilities are really endless.
They are.
But let's go back to this research for a second.
Okay.
They found that both the compost and the leachate were high quality.
They were.
And even exceeding standards for agricultural use in some cases.
And what's really interesting is that, these products could replace synthetic fertilizers.
Right.
Which we know can have some really negative impacts on the environment.
So we're closing the loop.
We are.
Using nature's processes to grow our food.
That's right.
And reduce our reliance on harmful chemicals.
It's really a great example of how we can work with nature instead of against it.
This research is really, supporting that idea.
Of creating a sustainable future by working with nature.
It is.
But, as with any scientific endeavor, this raises more questions.
Of course it does.
Than it answers.
Yeah.
For example, they only looked at, the physical parameters of the worms and the, chemical composition of the compost and the leachate.
Right.
But what about the long-term effects on soil health and plant growth?
Right. What happens when you actually apply this vermicompost?
Yeah.
How does it affect crop yields?
Exactly.
Nutrient uptake.
The resilience of those ecosystems.
Yeah, all really important questions.
Yeah, and this research, could be used to inform policies and initiatives to promote vermicomposting.
Yeah, imagine if every municipality had a vermicomposting facility.
Right.
Transforming that organic waste into a resource.
That would be incredible.
For local agriculture and gardening.
It would really change things, I think.
It would, but it requires a real shift in mindset. Seeing waste not as something to discard, but as a valuable input.
And that's where education and awareness, I think, come in.
Absolutely.
We need to tell people about the incredible potential of this.
We need to share this story in a way that, really connects with people.
Yeah.
Think about educational programs in schools.
Yeah.
Community workshops.
Yeah.
Even social media campaigns.
That's a good idea.
Yeah, showing people how magical this process is.
Instead of talking about, trash and garbage, we're talking about
transformation, renewal.
Yeah, transformation and renewal.
Yeah.
And imagine, kids getting excited about composting and understanding that connection between what they're eating and the health of the planet.
Exactly.
Yeah.
It's about fostering that sense of stewardship and empowerment.
And it's not just kids, it's adults too. Through community gardens, farmers markets, even partnering with local businesses to create these kind of closed loop systems.
Exactly.
It's really a shift in mindset from seeing it as a problem to seeing it as an opportunity.
Absolutely.
Yeah. But with all this enthusiasm, we should take a step back and think about some of the challenges that come with scaling this up.
Yeah. So one of the big ones is managing the variability of the waste itself.
Oh, okay.
It's not like a factory where you have really consistent inputs and outputs.
Yeah, each batch is going to be different.
Every batch is different.
Yeah.
Different moisture levels, nutrient content, even potential contaminants.
Right.
And that can really impact the efficiency and the quality.
The compost.
Yeah. So we need to develop systems that can handle those fluctuations.
And make sure that we're getting
very
consistent results.
Consistent, high-quality compost.
Yeah. So it sounds like we're going to need some high-tech solutions to make this work.
We need to bring vermicomposting into the 21st century.
Yeah.
I'm thinking, sensors and monitoring systems that can track all those key parameters.
Yeah.
Temperature, moisture, pH.
Yeah.
So we can make real-time adjustments.
Right.
We could even have automated systems that optimize the process based on the waste.
That's really cool.
It's like giving the compost bin a brain.
A smart compost bin.
And a smart compost bin.
Okay, but even with all this technology, we still have to figure out how to get the waste to the facilities.
The logistics. The collection, the sorting, the transportation. That's a huge piece of the puzzle.
And we don't want to create, other problems by doing this.
Exactly.
Like odors and pests, can be a concern with compost.
We don't want to solve one problem and create another.
So it sounds like we need to design these facilities really carefully.
We do. It's all about integration. Finding ways to kind of seamlessly incorporate this into our existing systems.
And be proactive about those concerns.
Exactly.
Yeah.
But even with all these challenges, the benefits are just too big to ignore.
Yeah, it really seems like this aligns with all of our sustainability goals.
Reducing waste, creating resources, improving soil health, community engagement.
It's a win-win.
It is.
All around, it seems like.
It really is.
As we wrap up here, it seems like this is going to require a lot of
collaboration
between a lot of different people.
Scientists, engineers, policymakers, community organizers, even artists and designers.
It's not just a science problem.
No, it's not.
It's, everybody needs to be involved.
It's a societal problem.
To make this work.
Yeah, we need everyone on board.
Yeah, and this research is really just the tip of the iceberg.
Oh, yeah.
We could talk about this forever.
There's so much more to learn. About optimizing those techniques. Understanding those microbial communities. Developing new applications for vermicompost.
And I think that's what I love about doing these deep dives.
You too.
Is that we uncover all these, new avenues for research.
It's a really exciting field.
Yeah.
With so much potential.
And I think the biggest takeaway for me is that we need to engage the public in all of this.
It's not just for scientists.
Yeah. How do we get people excited about composting?
We need to tell the story of vermicomposting in a way that really resonates with people.
Yeah.
Education programs, community workshops, social media campaigns.
Yeah.
Showcasing that magic.
Yeah.
Turning waste into a valuable resource.
So we're reframing it.
We are?
Yeah. Instead of talking about, garbage, we're talking about transformation and renewal.
Renewal, exactly.
And imagine, children being excited about this.
Understanding where their food comes from.
Yeah.
And how it can be used.
And how they can help.
Yeah. To create healthy soil.
Yeah.
To grow more food.
It's amazing.
It's pretty amazing.
So it's not just about kids, right?
No, it's not.
It's about community gardens, farmers markets.
Working with local businesses to create those closed-loop systems.
Absolutely.
It's really about changing how we think about waste.
It is.
Yeah.
It's not a problem. It's an opportunity.
It's an opportunity, yeah.
Yeah.
But I think we need to be realistic, too.
Okay.
Vermicomposting isn't the answer to everything.
Right. It's not a magic bullet.
It's not a magic bullet.
It needs to be part of a bigger strategy that includes source reduction recycling, anaerobic digestion, all those other approaches.
It's all about,
finding the right mix.
Finding the right mix.
Yeah.
And being adaptable.
Yeah.
Because what works in one place might not work in another.
Different communities are going to need different solutions. Yeah. But I think the overall theme here,
the big picture,
is that we need to move away from this, linear take, make, dispose model
towards something more circular.
Yeah.
Where waste is valuable.
That's been the theme of this whole deep dive, it seems like.
It has.
And vermicomposting can be a really important part of that.
It can.
This has been such a fascinating conversation.
It has been.
I've learned so much.
Me too.
It's amazing to think about all the potential here.
There's so much potential.
To really transform how we think about waste.
To create a world where nothing is wasted.
Yeah.
That's the goal.
So I think we should all channel our inner earthworm and start composting.
Let's get composting.
It's such a simple thing to do.
It is.
But it has such big impacts.
Big impacts
on the planet.
On our communities.
Yeah.
On ourselves.
Okay, well, this has been a great deep dive.
It has.
Thank you so much for joining us and
thank you for having me.
Sharing all this knowledge.
It's been a pleasure.
I hope everyone listening has learned a lot and is feeling inspired
I hope so too.
To make a difference.
Yeah, get out there and compost.
So until next time, keep learning, keep questioning, and keep composting.
See you next time.